According to the system, there was no danger. The status indicator was green. The readings were within acceptable ranges. Automated checks returned normal results, and the dashboard displayed the same word across multiple panels: safe. From a technical standpoint, there was nothing left to do. The system had spoken. This wasn't a single sensor or a human judgment call. It was a layered process involving multiple data inputs, real-time analysis, and predefined thresholds designed to remove emotion and uncertainty from decision-making. Once those thresholds were met, the outcome was considered reliable. The area was declared safe. Operations adjusted immediately. Monitoring was reduced. Personnel were reassigned. Resources that had been deployed under emergency conditions were scaled back. In some cases, equipment was shut down entirely to conserve power and manpower. That is what the system was designed to do. What it was not designed to do was question itself. The confirmation of safety was based on data collected during a narrow time window. Conditions were evaluated against models that assumed stability once certain indicators returned to baseline. Those assumptions had worked in the past. They were trusted. They had become institutional. But this time, something was missing. Several secondary indicators had not fully stabilized. Their values were technically within tolerance, but only barely. The system flagged them as acceptable and moved on. No alert was generated, because the numbers did not cross the line that required human intervention. From the system's perspective, there was no problem. From the ground, the picture was less clear. Field teams reported subtle inconsistencies, changes that were difficult to quantify but impossible to ignore. Visibility fluctuated. Environmental conditions behaved differently than predicted. Some readings lagged behind reality, updating too slowly to reflect rapid changes. Those reports were logged. They did not alter the status. The system continued to display green. As time passed, confidence grew. The longer the system showed no issues, the more the assumption of safety hardened into fact. Decisions were made on that basis. Movement resumed. Restrictions were lifted. People were allowed to return. No one announced that the system might be wrong. There was no procedure for that. The system did exactly what it was built to do. It compared incoming data to predefined limits and confirmed that nothing exceeded them. What it could not do was account for interactions between variables that had not been anticipated during its design. The danger was not a single spike or anomaly. It was a combination of factors, each individually acceptable but collectively unstable. By the time the first clear signs of escalation appeared, the system was already behind. Updates lagged. Alerts triggered late. The dashboard that had confidently displayed safe now struggled to keep up with rapidly changing conditions. Field teams began sending urgent messages that contradicted what the system was reporting. Confusion followed. Some units trusted the system. Others trusted their observations. Communication channels filled with conflicting assessments, all technically correct within their own context. Then the system changed its status, not from safe to dangerous, but from safe to uncertain. That transition alone should have been a warning. Instead, it was treated as a temporary fluctuation, a brief inconsistency that would resolve itself once more data arrived. The assumption remained that the system, given enough time, would stabilize the situation. It didn't. When the danger became undeniable, the response was reactive rather than preventive. Measures that should have been taken hours earlier were now being implemented under pressure. People who had returned based on the earlier confirmation were exposed again. The system issued alerts. This time they were accurate. They were also late. In the aftermath, the review focused heavily on the data. Analysts examined logs, timestamps, and thresholds. They verified that the system had functioned as intended. No malfunctions were found. No corrupted data. No missed signals. The system had not failed. It had succeeded, according to its own rules. The problem was not that the system declared the situation safe. It was that its definition of safety was too narrow. It could not recognize emerging risk that did not fit neatly into its models. It treated uncertainty as acceptable noise rather than a reason to pause. Internally, the incident prompted changes. Thresholds were adjusted. Additional indicators were added. New rules were written to account for combined risks rather than isolated values. But the core logic remained the same. The system would still confirm safety based on what it was programmed to see. For those affected, the distinction between system logic and reality was irrelevant. They had trusted the confirmation. They had acted on it. They had believed that safe meant what it said. It didn't. The most unsettling aspect of the incident is not that the system was wrong, but that it was confidently wrong. There was no ambiguity in its output, no warning language, no suggestion of caution, just a green indicator and a single word: safe.